So it gives me great pleasure to welcome up Karen MacKechnie. Karen is one of CCAP technical staff. She's been with us for 5 years, and she's been really kind of heading up the CCAP-ARIES lab together with Ryan. And they've been doing some tremendous work over the last few months. So, Karen.
Thank you, Mikey. As you all know, I'm Karen MacKechnie. I've been with CCP for over 5 years now as a support scientist, and I have the pleasure of going through a brief overview of ARIES scale-up and harvesting. So as Mikey said, we received almost over like £500,000 of funding for NERC. This was to increase our services, and from that we've got new kind of analytical and genomic equipment, which would be supported by the kind of scale up and harvesting equipment side. So with that kind of money that we received, we bought an array of lovely fancy new equipment. So here's kind of like a snapshot of what we got. So we got kind of an RO water system for creating media, which would be supported by UV systems for sterilising that, and also to process our waste. We also purchased shaking incubators as well for the kind of smaller size of the scale-up process. And probably what we would call maybe the kind of the star of the show would be our 4 times 70 litre photobioreactors, which we purchased for FERCon, as well as a membrane filter system from Membrology. We also got 60 litre centrifuge and a freeze dryer to process our biomass as well. Because, as Mikey says, CCP is very diverse. We have almost 3,000 strains in our collection. That can be kind of time consuming and take up a lot of space. So what we tend to do in CCP, we retain most of our cultures in kind of small volumes and maybe like test tube size. So we kind of have a challenge of how do we go from such a small volume like this to up to 70 or potentially up to 280 litres. And it's actually quite a relatively easy process. What we do is we do a kind of a gradual increase in volume, as you can see by this diagram, until we get the required volume for our photobioreactor. We kind of follow almost like a golden rule, where we kind of follow like a 10% of media culture, which we inoculated into 90% of fresh media. Obviously, that's dependent on the culture itself. We can increase that percentage depending on the strain requirements. Things like maybe cyanobacteria would maybe require maybe a higher percentage to be transferred. For example, maybe more than like 20 or even up to 50% of the culture transferred into new media. That video you see is basically as inoculating our carboy that has 9 litres of sterile media with a dense culture that we grew. What you see as well, we're using like a laminar flow cabinet on all our kind of like smaller size scale ups. We tend to use these cabinets to keep basically using kind of aseptic techniques to keep our cultures relatively as free from contaminants as possible. I'm not going to go into too much detail about the photobioreactors because we do have our expert in Marco from FERCon who probably go into a lot more detail and more than I possibly could. So what we tend to do when we're setting up the photobioreactor is we have with our RO water system, and we also purchase 100 litre holding tanks, which we keep separate. So we always have one just for fresh media, one for marine media. And to make our marine media, we use artificial sea salts with an array of pumps and UV systems to ensure that these salts are dissolved. From those tanks, the water is directly pumped into the photobioreactor. In CCP, we tend to use sterile stock solutions instead of powder. We find that it causes less stress to our strains. Powder form could possibly cause more precipitation. And also these stock solutions we've actually used throughout the whole scale-up process. So the strains are more used to these stock solutions. With the photobioreactors as well, we have 3 probes. We have optical density probe, solved oxygen, pH and temperature, as well as inlet and outlet pipes for pumping in the media or taking strains out. And everything for the photobioreactor is automated with a computer system as well. So once we have our cultures in the photobioreactors, like I say, with the pros, we can monitor these kind of dissolved oxidants and optical densities in real time. We can adjust light intensity and also create light cycles specifically for our strains. We also take regular samples from our photobioreactors to perform our own optical density for comparison, as well as cell counts where possible as well. We also actually take some samples as well for nutrient testing as well, to ensure that nitrates and phosphates are not depleted. We also inject CO2 with a mixture of air, and this is actually controlled at the moment in our photobioreactors with kind of on and off pH value ranges. So when it comes to time to kind of harvest the microalgae, we use our membrane filter system. Again, I won't go into too much detail because we do have another expert in store, Richie from Membrology, who will probably go into so much more detail than I can. So what we tend to do, we can pump our strain directly into the membrane system. The membrane system is comprised of a ceramic filter, and we can monitor things in real time as well with the system, from the permeability flow rate, average pressure, pressure drops, and temperature. And there we can create real-time graph situations, which means that we can monitor the performance of the kind of membrane system. What we can do as well when we're harvesting with the membrane system, we can take samples at any given point. From the samples, we can check our strains under the microscope for any kind of damage, how well it's concentrating, and checking for contaminants. And you can see from these pictures a before and after. And you can see from here as well that after post-harvest, there's not much damage or no damage to cells whatsoever, and it's nice and more concentrated. So in CCP with ARIES, we kind of have an aim and goal here at the moment where we don't want to be just confined to just doing macroalgae. We want both microalgae. We want to be able to grow up more wonderfully diverse strains. And what we hope, and we took this opportunity with the launch actually to trial a macroalgae. We decided to try asparagus strain due to its unique properties. We end up being very successful in growing it in a 10-litre carboy that you just saw there. We then harvest that material, and from that material, we then inoculated our photobioreactor with that material. And as you can see as well in the second video, how well it's actually growing. Now, we found it's actually quite easy to grow in the photobioreactor, but we had the challenge of thinking, how do we then get that out of the photobioreactor? How do we harvest that material? So this is when we decided to do adaptations to the photobioreactor. As you can see, we ended up putting a much larger outlet tap, which is then connected to a filter, which is then used, we then use a pump to directly empty the photobioreactor into that filter, where the material is then put into the filter mesh bag. The water is then carried on into a kind of a container. From the container, we then redirect that water back into the photobioreactor from the other side, causing that current you see now to make sure we get all the material. These are a couple of pictures of after our harvesting. So we can see the material is kind of this is like almost fish, but caught in the mesh bag. We then kind of emptied it into our buckets just to see what kind of wet weight we got. And another picture here of showing the kind of empty photobioreactor, just to show how well we managed to get almost all the material out. So sorry for going really fast, and my accent is probably everywhere. So what do we see the future developments for ARIES for the large scale and harvesting? But as I say, we want to make sure we're not just kind of pigeonholed or constrained and just doing macroalgae or microalgae, keep getting that mixed up. We're hoping to try new strains, such as polar diatoms, maybe snow algae, even maybe something like filamentous, like a cyanobacteria. This is what will allow us to maybe add more adaptations to our methods. we hope to carry on or even get new partners for more collaborations. In CCP, we annually have a very successful CPD course that we host, which includes things like isolation and how to maintain our cultures. We hope to have the kind of large scale and harvesting as part of that course in the future, or maybe even have it as a standalone course. We want to be able to continue our support with student projects and internships. And as Mikey touched on, we actually obtained our accreditation of quality management system, ISO 9000 and 2015. And we hope to maybe have ARIES under that scope in the future. And that would be a way to prove to our users that we do everything at a high standard. I ran that through that really quickly because I know we're kind of short with time. So I just want to thank everybody that's mentioned on that board. If I haven't included you, I'm sure I can find you a bottle of wine at the end of the day. Do we have time for questions or? Good, I can run away now. Thank you very much.